Hey folks, please set up your notes like this. We're going to do section 2.3 over a 2-day period because there is a lot of information in this section. Thanks for taking notes. I haven't checked your notebook yet, but I do expect everybody to have notes that, kind of look like this. It doesn't have to be, this horizontal bar and the vertical line. You can organize your notes however you like, but these are the main concepts that we're going to be talking about today. What does it mean to be an even or an odd function? We've already talked about some of that right there. What's it mean to be increasing or decreasing? And then where is there a local max or min, and what's an absolute max and an absolute minimum on a function? Okay, so let's try it like this. I'm going to give you a quick rundown over here of what each one of these means, and then I'm going to step through some slides to show you in greater detail. Okay, so let's start with even and odd functions. Now look, I'm going to underline something. Functions. See, we've talked about symmetry. This is all about symmetry. Okay, so we've talked about 3 different types of symmetry. One where it's symmetric about the y-axis. Okay, so let's just draw the old y equals x squared. Okay, so here's an example of a symmetric about the y-axis, and that is an even function. Okay, so this is an even function, and they give it that name. It's just a name. Okay, don't get too hung up on. I notice that this is an even exponent. Is it always going to have even exponents or anything like that? In this case it does. And I just don't want to get into any great, it has to happen like this or whatever. But remember that if we have some point x, y over on this function, there's got to be a negative x comma y. And it's easy to get mixed up. Like, it's weird that it's symmetric about the y-axis, but we're changing the sign on the x. And if you just think about it visually, I hope that makes sense. Okay? So the next type of function that we're going to talk about is an odd function. And I would say, the most basic odd function probably that we have is y equals x cubed. Okay, so I'm going to put that one down. And let's write down odd below that. So this is an odd function. And, we talked about that, symmetric about the origin. So this is symmetric about the origin. And so if you had some point over here, x comma y, you're going to have another one down here that matches it. Every single point over here is going to have a matching point down here, negative x comma negative y. And so you might be going, wait a minute, I only see 2 special names. These are just special names that mathematicians give these functions. What happened to the one about symmetric about the x-axis? Okay, so I'm going to put it down and then I'm going to undo it, and I hope I make this clear. So let's say you had x equals y squared. Okay, so here we go. Oh, wait a minute. That's not a function, right? So I'm just going to put that on here. Not a function. So we don't list symmetric about the y-axis, or we don't give it a special name because it's not a function. Okay, so I said I was going to undo it, but I think I'll just leave it there. Okay, so symmetric about the x-axis doesn't get a special name. That's why there's only 2 of them over here, 2 special names. And we've already done that stuff. So that, I hope, is going to be kind of easy for us. Now, I hope a lot of this is going to be easy, like increasing and decreasing functions, okay? So, or a constant function. Let's do this. Let's put down, again, like a basic parabola, okay? So let's say we have the basic parabola, but this one's going like this. Let's say it goes like this. All right, like it's going down. Well, there's going to be something called a vertex somewhere, and I'm just putting the vertex not on the y-axis. Let's say it's been shifted a little bit to the right. Okay, so this thing right here is called the vertex, and let me see if I can do this. Let me see if I can put this in yellow. Geez, I don't know if that's going to show up very well. So we're going to have this part right here where the function, if we're going from left to right, that's like reading in a book, like a novel. You read from left to right. As you go from left to right, the function is is going up, right? So see how the function is just going up, 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 up. So I'm going to put a little arrow out here. Let's see here. How can I do this? I'm going to put it in blue. Oh, shoot, man, that went to the yellow. Let's see if it'll go blue here. There we go. So the function's going up. That's the way I think about it. Like, that's increasing right over there. Increasing. The function, the y values are getting larger as we let the x values get larger. Now, if the y values get smaller as the x values get larger, that's called decreasing. So, I mean, it's really that easy. Now, you know, I think sometimes people get confused a little bit when they ask over what interval is the function increasing. So I'm just going to make up a number. Let's say that's x equals 1 right there. So I would say that it's increasing from negative infinity over to 1, and then I would put a parenthesis on 1. And the reason why I'm putting a parenthesis on 1 is right at 1, it's at the vertex. It's at the highest spot, right? So it's about ready to start decreasing. You might say, well, it seems like it's going up to get to that point, but at that point, it's like doing neither one. It's not increasing or it's not decreasing. It's at its maximum. It's at its flat spot right up there, okay? So we're going to put these intervals down over which the function's increasing, or we're going to put the interval down for where it's decreasing. So I would have, you know, another parenthesis, because we just talked about it's not doing either one at 1, not increasing or decreasing, and then it's going to go out to positive infinity. And we put parentheses on infinities because you never really get to a number called infinity. It's just a concept. So I already got it over here. That's decreasing. I'll abbreviate it. Okay, it's decreasing on that interval, and it's increasing on this interval over here. Okay, so they're going to ask you to do that. Now, that's increasing and decreasing. Let me go through a few slides, and we're going to summarize these two, make sure I didn't miss anything, okay? So I had a whole bunch of slides kind of queued up here. So we're trying to determine if function's increasing or decreasing. We're also doing even and odd, right? So if you plug in a negative x, do you end up with the original function back? That's how you determine if a function is symmetric about the y-axis or even. If you plug in a negative x and you end up with the opposite y value, then you have an odd function. So this is a even function. This is neither, I think, all right? If you rotate that about the origin, it's going to end up kind of like this part here is going to be over here creating new stuff. This one's an odd function. So we had even, neither, odd, okay? So that's a little review of that. And then how about an equation, right? Let's just do that real quick. Like if I plug a negative x, if I plug it in right there, you know, and right here, so f of negative x, I'm doing part A right now, I would get negative x. Remember how it's important to put parentheses around this? Some people lost like a point on the test because they didn't put parentheses around that. And a negative x squared is a positive x squared, like that. And hey, check mark, that means it's an even function, right? Let's look for, no, that's not, that's an even function right there. That's neither. Let's try this one right here to see if it's an odd function, okay? So I'm going to do part C. So if I go h of negative x, okay, I want to see if that's equal to the opposite of h of x. In other words, like the way we did is we said, well, negative y, if you plug a negative in for the y, and I know there's no y, that's just an h of x, so you kind of have to maybe replace the h of x, put a negative y down. This is one way of doing it. And then you go 5 times negative x cubed minus a negative x. Let's see what happens here. I get a negative 5x cubed, because a negative cubed is a negative, and then a negative times a negative is a positive, so I get positive x. Hey, this is just the opposite of what we started with, so this is an odd function, okay? Whew, I hope I made odd and even clear. And then we've got some more examples here, them plugging in negatives and all that kind of stuff. Here's what I was talking about with increasing and decreasing. Oh, I didn't talk about constant. This is constant right here. Like y equals 4 is what the equation looks like to me. Y equals 4 is just a horizontal line, okay? Now, where is the function increasing? Let me see if I can push this thing up because we can't see the bottom of it. Oh, geez. Let me try again here. Hold on one sec here. Let's go. Move up. All right. So let's see here. We've got, let's just do increasing for a second. We're going to go from here to here. I can see from left to right the function is going up the whole time, going up. So that's increasing. Now, how would I put that interval down? I would say from -4 over to 0, and I'm going to put parentheses on those. And let me try something here real quick. Why am I saying 0 and -4? Well, because look, -4 is my x value, -4 is my x value, 0 is my x value. So we're saying all of this stuff right here as we go from left to right, okay, the function is going up, the y values are going up. We're not listing the y values in the interval. They're going to ask the x interval. So I guess I could put like an x such that, or an x with a colon here. Usually such that's like a bar. But I want to remind you that we're always going to list, you know, the x values at an interval, and that's where it was increasing. Now, why did I do the one that was increasing? Why didn't I do the decreasing one? Well, hopefully you see this one's decreasing over here, and this one's decreasing over here. I don't know. I just thought I would do one of them. Okay, so I hope I'm making that clear. Those are really important ideas in calculus, and I don't think they're difficult. It's just that it's just, I don't know, people get kind of confused on why are we just listing the x values. That's a little confusing. Okay, so local min and max, that's a pretty easy idea as well. Let me just make a little graph here, and we'll talk about it. So let's say we have this graph. Don't you love it how my color doesn't come up the way I want it? I want black over here, and it goes to red. So let's try this. Let's say I go up for a little ways, then down for a little ways, then back up, and the function stops right here, okay? So I would say local mins and maxes, okay? So this is a local max right here, local max, because there's y values that are over here that are higher than this y value over here. So when we say a maximum, we're talking about the y value. Let's say that y value is 2. Well, I would say the local max happens at, let's say the x value is 3. The local max happens at 3, and its value is 2. So maybe you say local max f of 3 equals 2. And then let's say you have a absolute maximum at, let's say, 5. Okay, so out here, let's say this is 4. So then you say absolute max at f of 4, which was equal to 5. Okay, now what would this be right here? What would this spot be right here? Would that be a local max or a local min? Just try to answer that question for a second. Local, excuse me. Is it, obviously it's a minimum, right? It's a low spot. Is this a local minimum or an absolute minimum? Local minimum or absolute minimum? This is a local minimum, and the reason why is because, look, it's going down forever. So I would say there's no absolute minimum, because the function's going to infinity, or negative infinity, right? It's going to negative infinity over here. So there is no number called, you don't really get to a number. So I would say it's no absolute minimum. All right, I hope I'm making all these concepts clear. That's a long video. Sorry for it being so lengthy. Thanks for watching.